How do we randomize a list in C#? In this video, I'm going to create a simple method. Then briefly, I'm going to discuss the Fisher-Yates shuffling algorithm. And then we're going to make our method a little bit better. And finally, we are going to improve it even further and come up with the best version of the method that is used to randomize a list in C#. Okay, this is the first version of our randomize list method, which I'm going to use to show you how to randomize a generic list in C#. If you don't know what the generics are, you can watch my previous video, which I used to try to explain what the generics in C# are and how to use them. But basically, we have a list T, which is a generic collection, one of the many, and you can use the list with integers, doubles, decimals, custom classes, booleans, any type of object. And I also have a randomized list method, which is a generic method. You can see that we are using a T type, and it is used to randomize a list of any type. We can use it to randomize a list of integers, list of doubles, list of decimals, and so on. Let's take a look at the code quickly. We have a list of integers with 5 items, 1, 2, 3, 4, 5. We call the randomize list method, and then we loop through each one of the items and print them to the screen. So let's run the code and see what the output is. And we have a result 3, 2, 1, 4, 5. Let's run it one more time. 3, 4, 5, 1, 2, and one more time. Okay, and now I'm going to quickly discuss the Fisher-Yates shuffling algorithm that our method uses, and then we're going to go back to the code and we're going to make it a little bit better, because this method here is far from ideal and it can produce actually results that are not as random as you might want them to be. Okay, what is the Fisher-Yates shuffle of the Fisher-Yates algorithm? It's an efficient and straightforward algorithm for randomizing the order of elements in an array or list. As always, it comes with some advantages and disadvantages. There are faster algorithms out there, but this one is one of the most widely used, and mostly because it produces a uniformly random distribution of all permutations. In the description of this video, I'm going to post the link to the Wikipedia article where you can go and learn more about the Fisher-Yates algorithm. Now let's go back to our code and discuss the randomized list method that we're using to randomize the list in the program. The first thing that you might have noticed that we create an instance of the random class inside the method, which is not a great idea. And if you run this method in a very tight loop, in very quick succession, you might get results which are not as random as you might want them to be. So creating an instance of the random class inside the loop is not a good idea. We're going to fix that shortly. But first, let's see how our method works and how it implements the Fisher-Yates algorithm to randomize our list. Now let's take a look at the while loop, which is where we shuffle our list. The first thing we actually do outside the while loop, we create an integer called n, and we set it to the list count. In our case, we have a list with 5 items, which means that n is going to be set to 5, and we execute the while loop for as long as n is greater than 1, and then inside the loop we decrement n, which means that our while loop is going to be executed 4 times. And this is the line here, which actually chooses a random index from the list. If you don't know what the random next method does, it selects a number which starts from 0 and it goes up to the max value, which is our input variable. And in our case, k is going to be set to 0, 1, 2, 3, or 4 at random. And the next few lines, we swap the list k item with the list n, which is our current item. And this is how we shuffle the list. So let's run the code and see the output. Okay, so this is our original list, 1, 2, 3, 4, and 5. And inside the while loop, the first iteration, k, has been set randomly to 3, and n is 4, which means that we're going to swap the 2 items, which have indices of 3 and 4, and these are the 4 and 5 numbers in our list. And our list now is 1, 2, 3, 5, 4. Why? Because we have swapped the two items with indices 3 and 4. And the next iteration, k has been set randomly to 1, and n is going backwards from 4 to 3 to 1, so n is 3, which means that we're going to swap two items which have indices of 1 and 3, and our list is now 1, 5, 3, 2, 4. On the next iteration, k has been randomly chosen to be 2, and n is actually 2, which means that we are not going to swap any items since this is the same item, and our list remains 1, 5, 3, 2, 4, and the last iteration, k has been chosen randomly to be 0, and n is 1, which means that we're going to swap these two items from our list, and the final result is 5, 1, 3, 2, 4, and this is how our list has been randomized. We saw that our randomized list works seemingly well and can be used to randomize any list in C#, but it has a flaw. We are creating an instance of the random class inside our method, and this can produce unexpected results. The random class in C# uses a seed value to generate random numbers, and by default, if you don't specify a seed, like right here, if you don't have a seed, the random class is going to use the current system time, and if you create new random instances in very quick succession, like in a very tight loop, they are likely to get initialized with the same seed, and this results in generating the same sequence of random numbers for each instance. So instead of creating our instance inside the method, let's do something else. We're going to create the instance in our main method, and then we're going to pass the random instance as a parameter, and this is going to make our method better, because when random is initialized only once and reused, it makes sure that each call to the random next method within our randomized list is going to produce unique random sequence on each call. And not to mention, this is more resource efficient since we are creating the random instance only once, and allows us for better consistency and control. And of course, if you have a bigger program, you can use dependency injection to create our random instance and then pass it to other classes and methods. I just want to mention briefly that if you are creating a single instance of the random class and reusing it across your application, you still need to be careful if your application uses more than one threads. The random class is inherently not thread safe, and if you're creating a single instance and try to use it in several threads, you might run into some issues, but this is outside of the scope of this video, just something to keep in mind. Now let's discuss the final version of our code, which is used to randomize a generic list in C#. Instead of using the random class, we're going to be using the RandomNumberGenerator class, which is found in the System Security Cryptography namespace, and this is going to make our code even better. The random class in C# is actually a pseudo-random number generator, and it's perfectly fine for general purpose applications, but if you want to increase the randomness and unpredictability of the generated numbers, we are going to be using the RandomNumberGenerator class, which actually provides a cryptographically strong random number generator, and it is perfect for security sensitive applications where the randomness must be highly unpredictable. And if you take a look at our randomized list method, we have replaced the line that we used to generate the k, which is our random index from the list. Instead of this line here, we had the random next, and now we're using the getCryptoRandomNumber method to select our index at random, and again our list is going to be shuffled, and I have created a loop which shuffles the list 10 times. So let's run the code and see the output, and you can see that we still have 10 different lists, and which means that this method actually works. And if you need to code an application which is security sensitive, then you should be using the RandomNumberGenerator class found in the system security cryptography namespace. And if you are creating a general purpose application, then you can still use the random C# class. And that is all for me for today. Thank you for watching.